we have some really exciting news from the world of open source, particularly Deepseek. So imagine an AI that suddenly learns to think like a human, not because it was programmed to do, but because it kind of figured it out by its own. And that's exactly what happened in a moment that researchers now called the breakthrough that nobody expected. Let's actually take a step back. So here I've pulled up the research paper from Deepseek. And one thing that's fascinating is that during the training of Deepseek's R10, something unexpected happened. The AI started doing something that nobody programmed it to do. And it began thinking deeply about problems before answering them. But here's where it gets interesting. The model didn't just give quick answers anymore. It started doing something remarkably human. It would pause, reconsider, and approach the problem by saying things like, let me think about this step by step. And this wasn't programmed at all. It just emerged naturally. And the scientists called it the aha moment. And that is exactly what we have here in this paper, the aha moment of Deepseek R10. So here it says, during this phase, Deepseek R10 learns to allocate more thinking time to a problem by reevaluating its initial approach. Now, why does this matter now? You might be thinking, so what? An AI takes time to think? But here's why it's revolutionary. This was the first time we saw an AI develop its own internal monologue, and that too naturally by the looks of this paper. And it wasn't taught to think step by step. It just learned this naturally and thought it was the best way to solve the problems. And the AI actually became better at solving complex problems than the models were specifically programmed to think. And this suggests that AI can develop sophisticated reasoning abilities on their own. And when we think about mathematical problems where there's a clear right and wrong answer, something interesting happened because it kind of started doing reasoning by its own. But this Deepseek's paper came with a catch. The company used massive computing resources and millions of dollars to achieve this breakthrough. And it seemed like something only like tech giants could afford, even though it brought down the cost from like billions to now millions. It was still quite a lot. And that's where the story of today takes an unexpected turn. A PhD student at Berkeley was able to prove everyone wrong. He was about to show that the same aha moment, this same through breakthrough, could be reproduced for less than the cost of a dinner for two. And here is the post from this researcher. So it says, we reproduce Deepseek R10 in a countdown game. And there's a link that is open sourced as well to a GitHub repository. So this is quite fascinating. So all this was possible because of something called as reinforcement learning that's mentioned over here. So think of reinforcement learning like teaching a dog new tricks. When the dog does something right, it gets a treat. When it does something wrong, then no treat. And in AI terms, when the model gets to answer correctly, then there's a positive reward. When it doesn't, then there's a negative signal. But here's the clever part. This only works when there's a clear right and wrong answer. That's why they chose math problems, logical problems, and even coding problems. But you can't use this on like creative writing or opinion-based questions because there is no right or wrong answer and everything is a bit subjective. And they found the best results was on 3 billion based language model. They tried 0.5 billion parameters and they found that it was too small to think. And that is what we have in this graph down here, which we'll come to in a second. And 1.5 billion parameters started showing some signs of thinking, but then 3 billion parameters, that was the sweet spot. And 7 billion parameters worked well, but it kind of was an overkill. So the big discovery is the 3 billion model is all you need. And that's like finding you don't need a supercomputer, a decent laptop will do. So if you study this picture that we've got up here, so the basic process goes like there's some dummy outputs, just some random guesses. I'll explain the problem in a second as well. Then there's pure trial and error. Then in the phase 2, it develops some kind of tactics, like starts checking its own work and develops some revision strategies, creates some search patterns. And then in phase 3 is where we see the aha moment. There's an internal monologue that emerges, and then there's step-by-step reasoning and self-verification as well. And then if if you read through this thread, they also tried various other reinforcement learning techniques like proximally policy optimization PPO or GRPO, generalized reward weighted policy optimization, or even prime RL. And the result was they all worked about the same. It's like discovering you can bake a cake with different brands of flour. The recipe itself matters more than the specific ingredients. So, to prove that AI has learned to think, at least in this context, this researcher developed a simple game called the countdown game. And the problem was very simple. It has to use these four numbers to create an equation that equals to 65. Now, if you think about how a normal human being would approach this, there would be a lot of trial and error or some logic in here, and then eventually try to reason through that problem after each iteration and then come to the final result. Now, this game is brilliant because you just get a set of numbers and you need to reach a target number. And you can only use basic math operation, and there's always a definite right answer here. And like we spoke about, it's not a creative problem. So there is one and only one answer here. So if you exactly see how the AI approaches this problem, it starts off by checking a few iterations, like it reaches 72, and then maybe over here it does a few iterations, and then finally it gets to the problem where it says this equals 65. So in the initial approach, it looks at all the numbers and starts considering all the combinations, and then does all the verification like we just spoke about, and finally it gets to its destination. And all this internal monologue that we see here, it wasn't programmed at all. It kind of emerged naturally. And here's what it makes it mind-blowing. It's like it had different stages. So early training, it was like random guesses. And then eventually it moved on to check its own work, see if it was working or not. And then finally it came up to kind of sophisticated self-correction and multiple solution paths. And remember, all this just happened on the $30 setup, not $1 million infrastructure. And like we pointed out earlier, the researcher also tried this on different model, like over here Quen, with 0.5 billion parameters, 1.53 billion and 7 billion. And with small models, it hit a ceiling really quickly. And with larger models, they were able to get to the aha moment spike. And that is exactly what you see here. With the lower model, it kind of plateaus, but then with the higher parameter model, it kind of gets there really, really quickly. So what all this means is you can forget about thinking AI needs massive computing power. We are entering an era of tiny but mighty AI. And what we're seeing is 3 billion parameter models doing what used to need like 100 billion plus parameters. And then there'll be task specific AI that's incredibly efficient, models that can think deeply with minimal resources. And think of this like instead of one massive Swiss Army knife, we are moving towards a toolbox specialized for precise operations. Is like precise instruments. And here's where the breakthrough takes us. So test time training, models that adapt in real time and learning while they're being used and constantly improving performance. And the second one is task specific optimization. So thousands of tiny specialized models, each one expert in its own domain, and better results than giant models. And more importantly, because this is all open source, it democratizes AI development. Anyone can experiment and innovate. No need for massive budgets. Like if you look at this thread, you can just go in and start looking at this GitHub repository and try to recreate this yourself. And this is making research accessible for smaller teams as well. So imagine this future, every smartphone running sophisticated AI locally, and small businesses creating custom AI solutions, and researchers innovating without $1 million budget. So even though the current problems were only for simple math problems, the future possibilities are immense. Like imagine medical diagnosis or education tutor or scientific research tutors. Each one of these can be specialized and also affordable as well. So it's like the barriers are coming down and open source is the way forward. So if you liked this kind of video and if you found it useful, comment down what exactly you took out of this, and if you're going to be trying out some reinforcement learning yourself, and subscribe to this channel and hit a like on the video as well so that you get notified in the future when I put up more of these videos. Until next time.